Good. Now this is the next topic, what we call that binary logic gates. When we deal with analog and the digital signals, we don't forget about logic gates. So logic gates are the magical representation of computers, calculators, and other digital device. People use many electronic devices and their usages almost, but what are the magical in behind? That is another question. That is a logic gates or binary logic gates. Digital electronic devices are extremely logic in their natures. Almost when we say about digital electronics, we are extremely mean about their digital logical operations. There is basic building blocks of digital circuit, what we call logic gates. Logic gates are a types of gates almost logically designed to perform certain activities. Logic gates are used operated with binary numbers. Binary numbers are what binary means, almost two in terms of our formal numbers. So the binary logic gates are almost named in such ways. These logic gates are building blocks are for most complex computers and other electronic devices. These logic gates are by using simple switches, relays, transistors, diode and ICs, almost they are perform such types of activities. By using that, their availability, wide use, low cost can be make them acceptable at worldwide. Variety of these logic gates are almost available in all logic families, what we call transistor logic, and the CMOS, almost that is what we call logical families. Regarding to this one, we deal with digital signals. Almost what are digital signals? What are digitals, analogs? Almost you have understand certain points. Digital systems use binary numbers. Almost such types of digital signals which is needed for digital device is almost uses binary number system. Therefore, two-state devices are used to represent two binary digits, 1 and 0 by different voltage levels called high and low. When we say binary numbers, we don't forget about high or low. Means 0 or 1, almost in different voltage levels, we can say that it is high level or low level. If high voltage level is used to represent 1, the low voltage will be represented 0. If 0 is low level, 1 is high level. So this system is called positive logic system. We can say that it is a positive logic system. Why? 1 represents high level, low represents low level. It is called positive logic system. Between the low and the high levels, as you observed from this diagram, there is what? A gap or range. That is intermediate range. What we say is that a leading edge, a trailing edge, almost leading edge means from 0 to 1. When you are going from 0 to 1, there is a leading, means increased signals. When you come back from 1 to 0, it is almost a level which is reduced. That is the opposite ones. So this is called positive pulse or positive signal. Positive pulse or positive signal. On other hand, if the high voltage represents 0, what will come? And the low voltage represents 1, what will come? It is a negative logic system. It can be. When you make 1, it is represents low. When you make 0, it represents high. It is called negative pulse. It is respective diagram is also in opposite sides. Binary 0 and 1 represented by logic voltage 0 and positive 5. Almost we can say the low voltage represents 0, means the high voltage can represent 5 volts for DC especially. In positive logic system were represented by 5 volt or high, 0 represented by 0 voltage or low. In negative logic systems, almost, when we compare with the second diagram, 5 represents 0 represents 5 volts, 1 represents 0 volt or low. Both these positive and the negative logics are used in digital systems, but positive logic is more of the time, it is commonly now almost, but we can determine both in different cases. In reality, almost electrical circuit variations, 0 and 1 can be represented by voltage for particular systems, especially in this transistors family. Look, this one, almost, this is from 0 volts, 0.8 volts, 2 volts, 5 volts. Almost 5 is the highest or high level, 0 is the low level. What about the values between these? Means 0.8 and 2. That is called intermediate range, or most of the time we say that range. That is the values obtained between the high and the low logic system. That is almost practically we can get such types of result. Such types of things has its own signals. That signal can be represented in waveform. That is, they have their own waveform. Waveform can be characterized by different character. Most of waveforms encountered in digital systems are composed of series of pulses like this, T1, T2, T3. As you have seen, there is the low and the high levels, so these signals can be represented in such ways, and they can be classified as predict or non-predict. If it is repeated, we can say predict. If it is non-repeated, we can say that non-predict signals. A predict pulse waveform is one that repeats itself at fixed interval. For instance, a pred can be represented by capital letters T. So that is called pred. Pred 1 is equal to pred 2, pred 3, and so on. For the first signals, you can see from this pred we can get frequency. What is a frequency? Almost we say that frequency of DC is 0, frequency of AC 50. Such ways, what is a frequency? Frequency is the inverse of pred. Means frequency is equal to 1 over pred, or predict pulse train, we can say that. So frequency can be measured in hertz, that is the SI unit of that. Non-predict pulse is almost the inverse of that. As I have told you before, you can see that it is not uniform. That is why we say that non-predict frequency, predict pulse. And frequency of pulse or digital waveform is the reciprocal of the pred. The relationship between frequency and the pred is almost in such ways, frequency is equal to inverse of pred, or pred is equal to inverse of frequency. Here, a digital pulse has a predict waveform as we can say that Dati cycle. A Dati cycle is almost one full pred, almost. Dati cycle is equal to almost at least near to full cycle of pred, which is equal to around 75%. So Dati cycle is the ratio of the pulse width to the pred, and they can be expressed as a percentage. So Dati cycle is equal to pulse width divided by pred times 100%. Almost that is what we call Dati cycles. Good trainees. Here a self-reflective questions depending on what you have learned now. Almost what are binary numbers? What are the logic gates in binary numbers? Can analog device use binary numbers? If not, why? What intermediates or interminant ranges in binary digits? Why? What is the relationship between predict and frequency signals? You have to list out that, take certain breaks, and then we will come back to the second competence. Thank you very much.